Hello students, today we are going to continue the same chapter, natural numbers and whole number, and this is the part 7 of this chapter. And today we are going to talk about the properties of whole numbers for division. We have learned about the properties of whole numbers for the addition, for the subtraction and for the multiplication. Till now we have learned those things. Now today we are going to learn about the properties of whole numbers for division. So first property is there, closure property. Okay, so it says that if x and y are two whole numbers, then x divided by y is not necessarily a whole number. Okay, it means if we will divide one whole number by another whole number, then it is not compulsory or it is not necessary that all the time we will get the whole number as a result. Sometimes we will get the whole number, sometimes we will not get the whole numbers. It means the division of the whole numbers is not closed. It means the whole numbers are not closed under division, because all the time we don't get the result as whole number. So for being closed, okay, or to follow the closure property, if we are taking the whole numbers, then as a result also we should get the whole number only. Okay, if we are getting the same category, if we are getting the same type of number, it means whole number, then whole number. If we are taking the whole number, then result is also the whole number, then we say that okay, this is following the closure property. But here in the division, it is not necessary that we get the whole number as the result. It means whole numbers are not closed under division. So we can take the example here that 8 and 5. Okay, 5 and 8 are two whole numbers. Then if we will divide 5 by 8, then we will not get the whole number. We will get the fraction or decimal. We will not get the whole number. So it proves that closure property does not exist for division of the whole numbers. I hope that you understood. Okay. Now the next property is there, commutative property. Which property? Commutative property. It says that actually commutative property, what is the meaning of commutative property? That we can change the order. If we can change the order in the operation, okay, we can change the order of the number, and after changing the order of the number, if there is no effect on the result remains same, then we say that okay, this is following the commutative property. Like addition, 2 plus 3 is equal to 3 plus 2, because in the both the case we get 5. It means we have changed the order. 3 plus, in place of 2 plus 3 we have written 3 plus 2. Even then there is no effect on the result. It means the whole numbers are closed, commutative, okay, for addition. Okay, under addition the whole numbers are commutative. But today we are studying about the division. Let's see that division of the whole numbers are commutative or not. If x and y are two whole numbers, then x divided by y is not equal to y divided by x. It means if we change the order of the numbers in the division, then the result differs. We don't get the same result. The result does not remain same after changing the order of the numbers. It means we can say that division of the whole numbers is not commutative. You can see the example here that 3 divided by 5 is equal to not equal to 5 divided by 3. In both the case we get the different answer. If you divide this, then you will get something else. If you divide this, then you will get something else. But the numbers are same, but only we have changed the order. Then we are, after changing the order, we are not getting the same result. It means the division is not commutative for the whole numbers. Okay, division of the whole numbers is not commutative. You can take another example also. Suppose that 4 divided by 2. Okay, both are whole numbers. Then if we will divide, then we will get 2. But if we will change the order of the numbers only, 2 divided by 4. Okay, then what will we get? We will get 1 by 2. It means 0.5. So we have got that the result does not remain same. We get the different result after changing the order. It means the division of the whole numbers is not commutative. Now third property is associative property. If result remains same even after grouping, okay, changing the group of the numbers, then we say that yes, it is associative. But in the division we can't change the grouping of the numbers. Here you can see that if x, y and z are three whole numbers, then x divided by y divided by whole, y divided by z whole of y divided by z, means here we have made the group of y and z, and here the whole of x divided by y, okay, x divided by y whole divided by z. It means here we have taken the group of x and y, and here y and z, and if we'll solve like this, then we'll get the different result in both the cases. The numbers are same and all are in the division, but if we'll change the grouping of the numbers, then answer will differ. It means we can say that division of the whole numbers is not associative. We can't make the different group of the numbers. We can't change the grouping of the numbers in the division. Now, existence of identity. Existence of identity. Let me tell you one thing for this. For this division, if a continuous division will be there, suppose that the question will be that 16 divided by 2 divided by 2 divided by 2, then in this type of question what will you do? You can't make the grouping of these two numbers or these two numbers or these two. No, if this type of question will come, okay, continuous division is there, then what will you do? We will move from left to right. We will keep on solving. We will move from left to right like this. So here what will you do? First we will divide this 16 divided by 2, then we will get 8, and then divided by 2, and then divided by 2. Then we will take these two numbers, we will divide. So 2 4 are 8, and then divided by 2. Then we will get 4 divided by 2, then 2 is the answer. So whenever this type of case will come, this type of condition will be there, continuous division, then we will not make the grouping of any two numbers. No, we will just keep on solving from left to right. From left to right. I hope that you understood. If we will change the grouping of any two numbers, this or any two other numbers, then answer will be different. So that is not the correct way. This is the correct way, that we will keep on solving from left to right like this. 2 is the correct answer. Now we will talk about the existence of identity. The identity element for division of the whole number does not exist. Okay, it does not exist. Means what is the meaning of existence of identity? Which number is there that if we will divide that number by a particular number, or that any particular number will be divided by that. Suppose that I am taking any number x. Okay, so x is the whole number. So by which number will divide this number or any number? Suppose that I am taking 8, or 8 divided by x. In both the cases we will get different answer. So identity does not remain same. Identity, if the identity of the number will remain, okay, it means whichever number we are taking after the division, also the same number we get, then we can say that that number is the identity of the whole number for the multiplication. Like we had studied, know that if any whole number x is the any whole number, then if we multiply by 1, then we will get x only. If 1 will be multiplied by x, then also we will get x only. Means x will multiply by 1, or 1 will be multiplied by x. In both the case we will get the x only. Means identity remains same. So it is the multiplicative identity. So what is the identity for the what division? So there is no such type of identity or number. So because of that, the quotient will get the same number. So there is no that type of number. So identity element for the division of whole number does not exist. I hope that you have understood. Now existence of inverse. So inverse of the division is also not exist. We can't if you will just make the inverse, then the answer will be different. Okay, I hope that you understood. So this much only in this session. We'll continue the chapter in the next session. Till that time, all of you, bye, have a nice day.